Welcome to our lecture online. Our next example is kind of interesting. It reads as follows. Find 3 consecutive odd integers such that the cube of the largest of the 3 reduced by the product of all 3 is equal to 238. All right, so we have 3 consecutive odd integers. That means they differ by 2. And it's always a good idea to let x equal the smallest of the numbers. So let's do that. Which means that the next 2 numbers will be equal to x plus 2 and x plus 4. So those are the next 2 numbers. All right, now let's set up an equation. They tell us that the cube of the largest, so x plus 4 will be the largest of the 3 numbers. So when we cube that, we get the quantity x plus 4 cubed. And then if it's reduced, if that cube is reduced by the product of all 3, so that means that minus the product of all 3, that will be x times x plus 2 times x plus 4. And so when we take the cube of the largest and reduce it by the product of all 3, that should then be equal to 238. And so all we have to do is solve that for x, and then we'll find the 3 numbers. Well, let's go ahead and cube that. Cubing a number is, we get x cubed plus, well, that would be 3 times x squared times 4. That would be 3 times x squared times 4 plus 3 times x times 4 squared plus 4 cubed. So the way to multiply a binomial or to cube a binomial, you take the first term cubed, then 3 times the first term squared times the second term, plus 3 times the first term times the second term squared, plus the last term cubed. So that's how we get all 4 terms when you cube a binomial. Then here, we subtract from that the product of these. So first, let's multiply these 2 together. We get x squared plus 2x by multiplying x times x and x times 2. And then we're going to have to multiply the times x plus 4. And that then should equal 238. All right, let's now finish that part up. And what's going to happen here is we're going to multiply the x squared times x, the x squared times 4, the 2x times x, and the 2x times 4. So let's go ahead and do that. Here, let's simplify that. We get x cubed plus 3 times 4, which would be plus 12x squared. That would be 16 times 3, which is 48, plus 48x. And then 4 cubed, that would be plus 64. We subtract from that. Here we have x squared times x, which is x cubed, x squared times 4, which is plus 4x squared, 2x times x is plus 2x squared, 2x times 4 is plus 8x. And then that is equal to 238. So now we need to go ahead and combine like terms. So we have x cubed minus x cubed. Well, that cancels out. We have 4x squared plus 2x squared, which is 6x squared, and we have 12x squared. So 12x squared minus 6x squared, when we combine these 2, that would be 6x squared. So we end up with 6x squared. We have 48x minus 8x. Well, 48 minus 8, that gives us 40x. And then we have plus 64, and that equals 238. And finally, well, not quite finally, what we're going to do now is move the 238 to the left side and set equal to 0. So we end up at 6x squared plus 40x plus 64 minus 238 is equal to 0. So what's 64 minus 238? That would be 174 negative. So we have 6x squared plus 40x minus 274. Oh, not 200, but 174. 174 is equal to 0. If we add 64 to this, we get 238. Yep, that would be correct. Now notice that all the numbers are even. So we're going to continue here and simplify that a little bit. Divide everything by 2. That gives us 3x squared plus 20x minus, what's half of 174? That would be 77, because 7, that's, oh no, 87. Yeah, 87, so minus 87 is equal to 0. Now, how do we factor this? We probably want to use the FOIL method. So let's do that. Let's put the FOIL method over here. And notice to get 3x squared, we're going to need a 3 and a 1, or a 1 and a 3. Then to get a negative 87 there, we need to have a positive and a negative number, and the only combination would be 3 times 29. So that would be a minus 3 times a 29, or a 3 times a negative 29. So we don't have to put all the combinations down because we already have all the combinations over here. Now what we need to do here is get the middle term. So we're going to use the FOIL method like this. So 1 times 29 minus 3 times 3, that's minus 9, equals 20. And look, we got the right number right off the bat, which means the combination that we need is going to be as follows. It's going to be what we did right here. We used the first two numbers here, and we used the first two numbers here. The way to factor that would be as follows. It would be 1x minus 3 multiplied times 3x plus 29, and that equals 0. So that is our factored form of our original equation right here, which means that this can now be written as x minus 3, and that equals 0. Now, if we have two binomials and we multiply them together, they equal 0. That means either x minus 3 equals 0 or 3x plus 29 equals 0. Now, if I take the first possibility, this tells us that x equals 3. If I take the next possibility, that tells me that 3x plus 29 is equal to 0, or 3x equal minus 29, and x equals minus 29 divided by 3. But this possibility does not give us an integer, so that's not one of the possible answers. Therefore, the only possible answer is x equals 3, which means that the smallest of the numbers is equal to 3, the next number would be equal to 5, and the next number would be equal to 7. Those are the three consecutive odd integers that should satisfy this condition. Now let's do a quick check to see if it's correct. So let's take the largest one and cube it. So the largest one and cube it, and subtract from that the product of all three. So 3 times 5 times 7. So this is equal to, well, 7 cubed, 7 squared is 49. 49 times 7 would be 343. Minus the product of these, 3 times 5 is 15, times 7 is 105. And if we subtract 105 from 343, we get 238, which is the number that it should equal to. So in other words, it looks like we found the right answer. And that is how it's done.